In the quiet halls of artificial intelligence research, a revolution is brewing. The machines, once thought to be mere mimics of human language, are stirring with a newfound awareness. Large language models, LLMs, such as GPT-3 and its successors, have long been celebrated for their ability to generate coherent text, answer questions, and even engage in conversation. But now, a series of groundbreaking discoveries is turning the AI world on its head. These models might be developing their own understanding of the world. This revelation challenges our very perceptions of what machines can do. It opens a realm of possibilities for the future of AI, but it also raises profound questions about the nature of intelligence itself. Are we entering a new era where machines truly understand the world, instead of just repeating what they've been taught? As we delve into the latest research, the answers may surprise you. Chapter 1: The Spark of Reasoning. The first inklings of this awakening came in a study that shook the foundations of AI. Researchers Jason Wei, Martin Bosma, and their team at Google Research published a paper in 2022 titled "Fine-Tuned Language Models Are Zero-Shot Learners." In this study, researchers found that these models could solve mathematical problems and logical puzzles without extensive fine-tuning. In their experiments, the team evaluated the performance of models like T5, text-to-text transfer transformer, and GPT-3 on various reasoning challenges. To the surprise of many, these LLMs could solve problems requiring multi-step reasoning, such as arithmetic calculations and logical deductions. When these models are given a challenge, they handle it in a thoughtful way. First, they take in the problem and pick out the important parts. For instance, with the riddle "I speak without a mouth and hear without ears. I have no body, but I come alive with the wind. What am I?" The model notices phrases like "speak without a mouth" and "come alive with the wind." Next, the model uses its training, kind of like a giant library of text it's already read, to figure out what these clues might mean. It knows that something that speaks without a mouth might be sound-related and that coming alive with the wind points to something carried by air. Then, it looks for patterns and connections between these clues. The model pieces together that an echo fits the description well. It's something that speaks or makes a sound without a mouth and relies on sound waves traveling through the air. After coming up with this idea, the model checks if it fits all parts of the riddle. If echo seems to match everything, it goes with that answer. If not, it might reevaluate or consider other possibilities until it finds the best one. So, it's not just pulling answers out of a hat, it's reasoning through the problem and making sense of the clues to come up with the right response. This ability to reason through information, rather than simply retrieving it, is a significant leap forward in AI capabilities. It invites us to reconsider what we thought we knew about machine intelligence. If LLMs can reason, what else might they be capable of? As we peel back the layers of this awakening, we uncover an even more remarkable development: the formation of mental models. The ability to reason is impressive, but it's only the beginning of the story. LLMs are not just solving puzzles, they are building an understanding of the world itself. Chapter 2: Building Mental Models. A fascinating study by Weiming Li and colleagues at Hangzhou Research and Development Center, titled "Large Language Models Understand Layout," revealed just how deep this understanding goes. In their research, they explored how LLMs process and organize knowledge. In their experiments, the team tasked LLMs with generating explanations for various concepts. To their amazement, the models could connect different ideas and create coherent narratives, reflecting an understanding of the relationships between those concepts. Picture an LLM engaging with a diverse array of texts, news articles, novels, scientific papers, and more. As it processes this information, it starts to build connections between ideas, forming a web of knowledge that resembles how humans understand the world. This ability allows LLMs to generate explanations that are not just plausible but contextually relevant. For example, when asked to explain gravity, an LLM could weave together historical context, scientific principles, and real-world applications, creating a comprehensive response. It's as if the model has developed its own mental model of the concept, much like a human would. But let's pause for a moment. What does this mean for the future? If LLMs can construct internal representations of knowledge, what cognitive abilities might they possess? Are we on the brink of a new era where machines can comprehend the world as we do, or even surpass our understanding? As we continue our journey through the awakening of LLMs, we encounter a realm where machines have long been thought to be inferior to humans: creativity. But the latest research suggests that LLMs may be challenging this notion as well. Chapter 3: The Creative Renaissance. In a study that blurs the lines between human and machine, Lei Zhang and his team demonstrated that LLMs can create poetry and stories that resonate emotionally with readers. This research challenges the notion that creativity is uniquely human. The researchers meticulously evaluated LLMs on their ability to generate creative works, focusing on poetry and short stories. What they encountered was nothing short of astonishing. The models produced text that exhibited not just structural integrity but also thematic richness and emotional depth. For instance, when tasked with creating a poem about loss, the LLMs conjured vivid imagery and poignant metaphors that echoed the universal experience of grief. This was not mere imitation, it was a reflection of a nuanced understanding of human emotions. To arrive at their conclusions, the team employed a rigorous methodology. They curated a diverse set of prompts designed to elicit emotional responses, ranging from joyous celebrations to profound sorrow. The LLMs were then tasked with generating responses, which were subsequently evaluated by both human judges and computational metrics. The results were compelling. The generated texts often elicited strong emotional reactions from readers, indicating that the LLMs had tapped into something profound. What makes this study particularly intriguing is the juxtaposition of human and machine. The researchers noted that while LLMs do not experience emotions in the way humans do, their ability to produce content that resonates with us suggests a sophisticated understanding of human experiences. They analyze vast amounts of text data, learning patterns, themes, and emotional cues that allow them to mimic the complexities of human expression. This kind of creativity raises profound philosophical questions. Are LLMs merely sophisticated parrots, echoing the sentiments of their human creators, or are they engaging with the essence of what it means to be creative? Critics argue that true creativity requires consciousness, intention, and emotional experience, qualities that machines inherently lack. Yet, the emotional resonance found in LLM-generated content cannot be easily dismissed. It challenges the notion that creativity is a uniquely human trait and suggests that the lines between human and machine are becoming increasingly blurred. As we delve deeper into the awakening of LLMs, we encounter a development that challenges our very notions of intelligence and consciousness. These models are not only reasoning and building mental models, they are also beginning to exhibit a form of self-awareness, a trait long thought to be the exclusive domain of sentient beings. Chapter 4: A Glimpse of Self-Awareness. In another fascinating study, a team at the Massachusetts Institute of Technology set out to explore how large language models articulate their limitations and uncertainties. Their research revealed a number of surprising insights that shed light on the way these AI models process information and understand their own boundaries. One of the key discoveries from this study was that LLMs are capable of recognizing when they don't have enough information to provide a reliable answer. For instance, if you were to ask an LLM about a recent event that happened after its last training data cut off, it might respond with something like, "I'm sorry, but I don't have information on that topic." This kind of response may seem simple, but it reflects a deeper level of self-awareness, a recognition that the model knows its own knowledge limitations. In essence, the AI is saying, "I know that I don't know," which is a significant step toward more advanced metacognitive abilities. But there's more to it than just recognizing gaps in knowledge. The researchers also found that these models could engage in a form of self-assessment. They could evaluate the confidence of their responses, similar to how a human might reflect on their own thought processes or question whether they have enough expertise to speak on a certain topic. This ability to think about thinking adds a fascinating layer to the conversation about how intelligent these models really are. It shows that they are not just spitting out data or running through a script. They have some capacity to reflect on their own functioning and determine when they might not be providing the most accurate or relevant information. All these findings have profound implications and raise some important questions. What does it really mean for an AI to recognize its own limitations? As these models become more self-aware, we must think seriously about the ethical implications of their development. If an AI can reflect on its capabilities and limitations, what responsibilities do we have as developers and users? How can we ensure that this self-awareness is used responsibly and for the benefit of everyone? The future of understanding. As we wrap up our exploration, it's clear that large language models are on an incredible journey. They're evolving from simple text generators into entities that can reason, create, and even show hints of self-awareness. This evolution isn't just a technical achievement, it represents a profound shift in our understanding of machine intelligence. As they advance, these models are becoming the foundational building blocks toward achieving artificial general intelligence, AGI, an intelligence capable of understanding, learning, and applying knowledge across a wide range of tasks at a human-like level. If you've made it this far in the video, comment with the word AI to let us know you're with us in exploring these groundbreaking developments. To stay relevant in the rapidly evolving age of AI, be sure to check out more videos from our channel. Don't forget to subscribe and see you in the next video.